Hello again, and welcome to part 3. So here we're going to talk about cognitive processes. So cognitive means what you do in your brain to solve problems, make decisions, weigh different decisions, and everything you do logically is part of your cognitive processes. So we'll go over learning and memory, long-term memory, how we remember things, and then language, how we learn and remember language. So let's start with the two main ways of learning theories that have been discovered, and you may or may not have already heard of Pavlov. So this was a Russian. He studied science, or he became a doctor actually, and won a Nobel Award while working with dogs and doing studies on them. When he noticed that, so he would ding a bell every time it was time for the dogs to eat. And he noticed after a while that after dinging the bell, the dogs began to salivate due to they connected the sound of the bell to food being given to them. So from that, he created what's called associative learning, and it's called conditioning, where someone will get used to a stimuli like a bell, and when it is simultaneously brought with food, the brain will automatically connect the two. So that's why we see when the Pavlov's dogs hear the bell, they would salivate, even if there's no food. So that's one way the brain can learn, is through stimuli and then receiving something, and then it can relate those. And then we have B.F. Skinner's operant conditioning, is where things were taught and learned with reinforcement, so rewards. So there can be positive reinforcement, giving someone a prize, or negative reinforcement is when you take away something that the person wants. If they don't do it the right way, that's another reinforcement to teaching different things. So that's another theory of learning. And then we have, so the best way that I've found myself through teaching and that psychologists have studied is instead of giving a reward every time for something good, because then the person will get used to having a reward. And later, when there's no reward, they will have no motivation to do the task or whatever they needed to do to get the reward. So the best way that's been found to combat this conundrum is by partial reinforcement. So not every time giving a reward, but maybe once every other time, and so that the child or person does not grow accustomed to a reward but continues to learn. Because what that can lead to is when a reinforcement goes away, the learner may stop wanting to do any behavior that was he was doing to receive the reward. And that's called extinction, when a reinforcement goes away along with the person's behavior. And now there are two different types of conditioning. There's operant, which is voluntarily, where people actively choose to do something, and they use stimulus simultaneously while giving or doing an action to get a response. So an example of that is Pavlov's dogs. They involuntarily start drooling when the bell is rung. And then we have classical conditioning. So classical conditioning is involuntary. Response is automatic or reflexive. The stimulus comes before the response. And sorry, I got them mixed up. Classical conditioning is what Pavlov used, which is the involuntary. You hear a bell and you start to salivate. And then operant conditioning is when we try and reinforce the behavior with punishment or rewards to learn by. So that's operant conditioning and classical. And now let's talk about areas of the brain's cognitive system. So what we use to do math, make decisions, all these complex cognitive processes. So the cerebellum is the area which encodes, processes, and sends memories to be stored. So it does a lot of work for many different signals that it receives. And then the motor cortex in the frontal lobe is in charge of motor skills, like using your body. And it also plays a role in classical conditioning. Learning through association and reflexes is done from the motor cortex of the frontal lobe. And they discovered about these specific areas of the brains through some case studies on animals, and specifically rabbits were found to have damaged cerebella, and that made them unable to be classically conditioned. So the cerebellum plays a huge role in conditioning and learning involuntary actions related to stimuli. All right, then we have the hippocampus, which is your memory storage center. The cerebral cortex is the gray matter that's all around your brain. It helps with sending, receiving signals. It helps with boosting your brain activity levels. It helps you to acquire skills. It helps you create tools and many other things. And it even makes up more than 80% of the brain's weight. It involves IQ and personality, and it's said to be the center of the conscious mind. So this gray matter, the cerebral cortex, is very unknown about, but it assists in lots of things, almost everything. So the gray matter is full of neurons and blood vessels, axons, dendrites, and glial cells that all assist in the functions we do each day. And then we have the more areas of the brain. The frontal lobe is responsible for thinking, planning, memory, and judgment. The left frontal lobe has Broca's area, which is important for learning speech and language, which we will cover in a moment. The parietal lobe is responsible for processing information about touch and space. The occipital lobe, which processes visual information. The temporal lobe for hearing and language. The motor cortex controls and executes movements. The primary, we learned about the somatosensory cortex, which takes in touch and pain and temperature and generates a response due to what the body felt. Then the visual cortex handles what we see. And now we are on types of memory. So there are different types and categories of memory which get stored and used in different areas and ways. So explicit memory is what? It's also called episodic memory. Means what you remember of what happened. So personal events, memories, life experiences are all explicit or episodic memories. And the next is semantic. So semantic means general knowledge, concepts, the encyclopedia of the brain. And so then we have implicit or procedural memory, which is the body's almost muscle memory, where it knows how to do something. Maybe someone's played piano for years and can just play piano without much thought, or riding a bike. And then we have emotional memory, which is feelings, moods, or how you emotionally react to something. And all of these different types of memories are stored in separate parts of the brain. For example, the hippocampus stores the important life event and experiences memories. It holds all of that. And then the amygdala holds the emotional related memories. The prefrontal cortex, which is in charge of executive functions, is what holds the working memory. So working memory is short-term memory, what we use to solve some problems, and then it does not go into long-term memory. Just use it for action. All right, now we get to some real long-term potentiation, LTP, which is when information is sent into long-term or permanent storage in the brain. So how memories or information is processed and sent into long-term memory is a process that requires repetition. So the brain needs to see these things or hear these words again and again. It's about repetition, and it's also about use. So when you use that thing you want to learn and use it in context, that really makes it more concrete, that it will be sent to long-term memory. So how this works is these are the synaptic vessels, the AMPA and the NMDA. So inside the synaptic vessel, under those are the gates to the long-term potentiation storage area. And it isn't until action potentials open the gates and allow the positive ions into the cleft and enough positive energy inside that it will open the gates and allow the stimuli or information to enter long-term memory. So the channel is usually blocked by magnesium, and it needs strong signals to open it. So when you're learning, maybe repeating or using that thing will keep sending a signal, and if there's enough and strong enough signals, it will be sent to permanent storage or long-term memory. Now we'll look about language learning. So there are two important areas of the brain that are responsible for language. So the Broca's area and Wernicke's area are critical for language. The Broca's area is responsible for the motor functions, allowing us to formulate syllables. So your tongue, your jaws, your throat, everything that helps us pronounce and form the language we speak. And damage to the Broca's area has resulted in speech impairments and trouble forming syllables, but not trouble with actual language acquisition or use, but the problem speaking. Then the Wernicke's area is responsible for understanding what language needs. And damage to this area does not affect the ability to speak. However, it could result in nonsense being spoken, because that is the area that holds language. And when that's damaged, there will not be language to use. So there are different pathways for language in the brain. So, for example, when we are reading, information is sent to the primary visual cortex. Then it is sent also to the angular gyrus for auditory signals. So your brain will send what you read to a different area to turn it into words in your head. And that's the voice in your head. Then it will be sent to Wernicke's area to understand what's being said. And then to the Broca's area where we can respond. And the primary motor cortex is also involved in this. And then for just spoken language, signals are sent to the primary auditory cortex, where it is translated and then a response is generated. It is sent to the Wernicke's area for translating, comprehension, and then sent to the primary motor cortex. Here are some fun facts. So, alcohol, just like glutamate, binds to NMDA receptors in the long-term potentiation area. So, by binding there, it makes it much harder for those clefts to open and information to enter long-term storage. So alcohol can prevent memories from forming. And also about long-term potentiation or long-term memory, dopamine plays a large factor in what is sent to memory storage or not, because the more exciting and fun and enjoyable the memory was, the more likely it will be stored in long-term memory. Another fun fact is that the hippocampus can grow in size just like a muscle, especially when used for specific tasks such as navigation. And some other ways to naturally boost brain activity while reducing stress is to exercise, because exercise will naturally increase brain cell growth and activity. Sleep gives the brain and its functions time to rest and repair itself. And the third natural way is meditation. So meditation will boost neuroplasticity. It will help the synapses and neurotransmitters strengthen and become more active and ready to do your daily functions. And neurogenesis, which is the formation of new neurons, so maybe learning new things or new concepts, can happen throughout your life, throughout adulthood. All right, that is the end of part 3. Now part 4 is about some disorders. However, we will only go over one, the major depressive disorder, or MDD. So MDD, major depressive order, has specific criteria that need to be met in order for it to be diagnosed as MDD. So criterion A, there must be at least 5 symptoms for at least, I think, 2 weeks of time, or it might be 6 months. But anyways, so some common symptoms of major depressive disorder are low mood, trouble sleeping, you lose interest in doing what you like to do, you have low energy, tired, you can't concentrate, appetite changes, and even suicidality. And so people are assessed based on a criteria A, B, C, D, and E to have MDD, major depressive disorder. So they need to have 5 of those criterion A symptoms. Then criterion B, it must cause a significant issue in the life of the person. So maybe it causes trouble at work, it causes lack of sleep, it causes bad moods all the time. So there's many ways depression can cause issues in anyone's life. Criterion C makes sure that the symptoms are not due to other causes, such as drug addictions or any other psychiatric condition. So make sure that it is from major depressive disorder and not other related disorders which can have some of the same symptoms. Criterion D is that it's not schizophrenia or a similar disorder, because many of them have the same symptoms. Criterion E is that it's not bipolar disorder, and that the patient has no manic episodes, because if manic episodes are only related to bipolar disorder, not major depressive disorder. All right, so people who have major depressive disorder, here are what they go through. So there's less gray matter activity in the brain. So the cerebral cortex, which is 80% of the brain's volume, which has all the neurons and synapses and assists in signals being sent to their destination, has a lower activity. Therefore, people with depression have a harder time with problem solving. They have more stress there, and they have a harder time concentrating, even and paying attention. And also the hippocampus will shrink due to depression, and that will cause difficulties with problem solving, attention, and as I said, and the prefrontal cortex is the area in charge of our executive functions, so like real complex problems. So those will be affected because there's lower activity in those areas of the brain. Many different areas of the brain are affected, including GABA, serotonin, norepinephrine. There can be a decrease in the amount of the body's necessary natural neurotransmitters released. So glutamate, let's look at a few of these. So in major depressive disorder, glutamate is related to learning, cognition, memory, mood regulation. So that is lowered, the body has less ability to combat those problems. And gamma or GABA is relaxation and sleep. That's affected. Dopamine, there's less dopamine released. People are more sad. Serotonin helps regulate mood and sleep. That's affected. And even norepinephrine, which helps you focus and pay attention. All right, and what causes major depressive disorder? So there is a variety of factors that can cause major depressive disorder. The main reason is believed to be the environment around each person. So many different things from your environment can have an impact on your mental health. So especially the people you're around, moods and emotions are sometimes contagious. So whoever you're around most of the time, if it be your family, your coworkers, their moods can spread to you. So being in a positive environment can really help your mental health, versus being in a negative environment can actually push someone into depression. And studies have shown that, so many people thought depression is hereditary. However, studies have shown that even adopted children have adapted from being in a family that is genetically depressed. Just from being in that environment, they also developed depression. So it's not only genetical. It's not only about genetics. It's mainly and more so about your environment, your perspectives, and some things we can do to help that is physical activity, nutrients. They help with the suppression of stress. And so the most impactful factors found leading to MDD were stressful life events and problems through childhood. So it can be an event, it can be your environment. So there are many causes of that. As you can see in the above diagram, can be even substance abuse, financial problems. So how do we treat MDD? So 1 in 3 people found that cognitive behavioral therapy alone, with no medication, nothing else, can improve their symptoms. So medications are not always necessary. Sometimes they are. However, cognitive therapy attempts to rationally and logically think through why you're feeling depressed. Try to find the root, and then cognitively find ways to focus on the positive, find ways to get out of that depressed thinking mode. So there's also therapy and medications that are commonly used, like antidepressants, SSRIs. They're very commonly used to treat depression and do so very successfully for many people. Exercise and healthy diets increased the activity of neurons that can combat stress. So exercise and eating healthy helps you keep stress away. And therapy, along with medication, helps many to adjust to a new mindset while receiving some of the medication to combat the neurological imbalance between stress and the normal hormones. Educated guidance by professionals is really the best way to handle depression, and really requires thought, behavior, and change in perspective. And so, on that note, Jesus says in the Bible to not be anxious, but to be thankful. And fear is released from the amygdala in the brain. And people have found out through studies that that same fear center in the brain is also where gratitude is released. And when there's gratitude, thankfulness in the amygdala, it will push out the fear or stress. So being thankful can take away stress by changing your mode of thought into something positive, and that will even take over the amygdala, which is in charge of fear. So that's pretty amazing, I thought. So, summary of what we learned here. So, the brain is amazingly complex. I am amazed as I learn more and more about all these different things. And the sleep is very important. Get enough sleep. Exercise. Super important. You want to be happy? Exercise. Sleep. Meditate. And then long-term potentiation, long-term memory takes repetition, and also when you incorporate different senses such as touch and do something physically while learning, it will increase the signals sent to the long-term memory and increase the likelihood of it getting sent to long-term storage. And then stress's effects on the brain are completely devastating. It impacts so many different areas, from decision making even to your hormonal levels will be messed up. And there is lots more about that, but that's all for now. Thank you for watching, and if you want to learn more about anything that was here, here's a list of all the sources, and feel free to go through them. There's some great sources there. Thank you, and peace.